Hi, everyone. This is Professor Ronald Howard. He's the father of decision analysis, and he's taught many students from Stanford's business school. This professor gave me the most fascinating test I've ever taken in my life. It was the midterm in his decision analysis course. Now, here's what the midterm basically looked like. It was 20 questions based on the material of the course, and each of the 20 questions had 5 options, A through E. Now, you might be looking at this and you might be going, oh, it looks like a Scantron exam. No, no, no. This was not a Scantron test. Each problem had 5 slots corresponding to the 5 possible options, A through E. You did not just check off the one that you thought was correct. You had to assign a probability distribution to each question. So, for example, do you see what I mean by that? For example, if you thought there was a 60% chance that the answer to number 20 was B, you put 0.6 here under B. If you thought that there was a 10% chance the answer was A, you put a 0.1 under A. Maybe 10% for C. Maybe 20% for D. And maybe a 0 for E. Now here, I should put a sad face instead, and I'll tell you why. Okay, so this was a strange test. You had to assign a probability distribution for each of the 20 questions. Now, if you left an entire row blank, then the computer would automatically put a uniform distribution. So the computer that graded the test would automatically put 0.2 or 1/5 for each of the 5 options, automatically, if you turned in a blank row for a question. In fact, there were some students who took the test, they got the exam, they put their name on it, they left the rest of the exam blank, they turned it in to the TA, the teaching assistant, and they actually did better than some students who turned in a paper with some numbers in it. Because it was possible to get negative points on some of these questions. And what was the absolute worst thing you could do? What was the absolute worst thing you could do? The worst thing you could do was to assign a 0 probability to an option that turned out to be correct. Only one of the 5 options was correct for each of these problems, like usual. But you had to assign a probability to it, or the computer assigned like a 0.2 for you. If you put a 0 on what turned out to be the correct option, you automatically got a negative infinity for the raw score for the exam. Now, actually, in the end, the scores were renormalized so that even these people ended up with like a 50% or something. But this was very bad. You don't put a 0 probability on something that turns out to be right. Because when you assign a 0 probability, like I said earlier, that's a very powerful thing to say. If you say that something is correct with probability 0, what are you saying? You're saying that it's impossible that E in this case is correct. Well, if you say it's impossible that E is correct and E turns out to be correct, then that's a very embarrassing thing for you to say. So you deserve a negative infinity as your raw score. Actually, I remember one problem where I assigned a 0.8 on an option I wasn't sure of, but I spent so much time on number 3, for example. I spent so much time on number 3, let's say, that I was frustrated and I just wanted to assign a high probability so that I could get a lot of positive points. I believe I got that question wrong and I ended up losing points. I got negative points on the problem. And that was a lesson to me to not engage in the sunk cost fallacy. Look that up. That means that you shouldn't base your decisions too much on the time or investment you placed in it beforehand. So you shouldn't be focused so much on the sunk cost when making your decisions now or in the future. Some of you might apply this to your current personal relationships. Oh, I spent so long with this person, I got to keep going. You might be engaging in the sunk cost fallacy. There were actually a couple of people who did this. They put a 0 on what turned out to be the correct option. They got negative infinity as the raw score. And Professor Howard just shook his head. He looks like a sarcastic Santa Claus. He just shook his head. He swiveled in his chair and he said, "Some people never learn." Oh, and how is a negative infinity possible as the raw score? Well, what the computer did was it took the probabilities that people assigned to what turned out to be the correct answers, and the grading scale was logarithmic. Do you remember how to graph logarithms? I'll go to desmos.com. You know desmos.com? Let's graph y equals the natural log of x. As x approaches 0 from the right, you see what happens? The y-coordinate, the function value, approaches negative infinity. That's calculus. So based on that logarithmic grading scale, if you put a 0 on the correct answer, then you got negative infinity as your raw score. This was the most fascinating test I ever took. I did pretty well in it, although I lost some points on this one that I learned about sunk cost fallacy on. But it was a fascinating test. I hope you never have a test where you face the prospect of getting negative infinity, though. Good luck.